Hello, good morning. I am SEEMA GARG. Today video 81, lecture 19. It is for BSc Part 1, Organic Chemistry, Paper 2, Alkenes. Introduction. Unsaturated aliphatic hydrocarbons containing two hydrogen atoms less than the corresponding alkanes and which are characterized by the presence of the double bond in their molecules are called alkenes. Olefins. Olefins means oil forming. Because alkenes, lower alkenes like ethylene, form oily products on reaction with halogens such as chlorine and bromine. Its general formula is CnH2n, where N is 1, 2, 3. Unsaturated aliphatic hydrocarbons. Alkenes may be classified according to the number of double bonds present in the molecule. If it contains two double bonds, they are called alkadines. If three, then alkatrines, and more than four double bonds are called polyenes. Nomenclature. Common name, alkane, N is replaced by Y-L-N-E, L-E-N-E means lean, like ethane is ethylene, right? So it is a common name. Where IUPAC name, alkane N is replaced by ENE, means ethane is ethene. Structure. See the common structure of the alkene molecules. Ethene, its common name is ethylene, and IUPAC name is ethene. This molecule common name is propylene and IUPAC name is propene. This molecule double bond on first carbon in between the first and second carbon, so it is alpha butylene, its common name, and IUPAC name is 1-butene. This in between the second and third carbon double bond, it is called beta butylene, common name, and IUPAC name is 2-butene. This molecule isobutylene, its common name, and IUPAC name is 2-methyl propene. Let's see some IUPAC nomenclature of alkanes. We have to give numbering. We have to keep first priority we will give to double bond and then the substituent. 2,3-dimethyl 2-butene. Here 3-methyl, longest chain we have to select 3-methyl 3-hexane. 3-ethyl 2-methyl 1-pentene. See here, longest chain 3-ethyl group. This one is on 3-ethyl 2-methyl 1-pentene. Right. 3,4,4 trimethyl 1-pentene. Alkenyl group, vinyl group. This is called vinyl or ethanyl group. And this is propenyl, 1-propenyl group, 2-propenyl group. Molecular orbital structure of ethylene, it having sp2 hybridization. See the molecular structure, bond angle is 120. It contains 1 sigma and 1 pi bond. As we know, carbon-carbon bond length is 1.54 angstrom. Here in carbon double bond length is slightly decreasing. It is 1.33 angstrom. Carbon-hydrogen bond length is also affecting. In sp3, it is 1.09. In sp2, it is 1.07. Bond dissociation energy. Carbon-carbon sigma bond having energy bond require 88 kilocalorie per mole energy. Here in alkene, it contains sigma and pi bond. Sigma bond require 95 and pi bond require 51. So total is 146, but pi electrons are delocalizing. Due to this delocalization or loosely bounded, uh, easily any reactant, any electrophile can attack to the molecule. Methods of formation. Most of the methods of preparation of alkenes involve elimination reaction, 1,2 elimination or beta elimination reaction. So in general, it is eliminated and gives this XY is eliminated and gives alkene molecule. X and Y may be same or different atoms or group. Dehydration of alcohol. When an alcohol is heated with strong acids such as sulfuric acid or phosphoric acid, alcohol is converted into alkene with the removal of water molecule. That is, it is also known as a dehydration. It can be carried out in presence of alumina, sulfuric acid, phosphoric acid. So dehydration in presence of alumina or H ions strong, it will give you alkene. The reactivity order of this alkene is tertiary alcohol is more reactive than compared to secondary than primary. This we can explain on the basis of the reactivity. See here, primary alcohol, it requires 90% sulfuric acid and 180 degree centigrade temperature, means a drastic condition we require to convert it into alkene, means propene. Whereas secondary alcohol, it requires less concentration of sulfuric acid and 100 degree centigrade temperature. It will again give you alkene, means propene here. Tertiary alcohol, it requires very less concentration of sulfuric acid. It is about 20% and temperature is also less compared to primary and secondary. It is 85 degree centigrade and it will give you isobutene. So on this basis, we can say the reactivity of tertiary alcohol is more compared to secondary than mechanism. First, alcohol is protonated. Alcohol group is protonated and it will give this hydronium ion. And this slowly eliminated, H2O is eliminated and it is a slow step and only one molecule is taking part in the reaction here in a slow step. So it is called E1, E1 reaction or E1 mechanism, elimination reaction. And then this water molecule will abstract the another proton of the molecule and it is a fast step and it will give you alkene. Residue selectivity, structural orientation, Satzjeff rule. Dehydration of unsymmetrical, that is secondary or tertiary alcohol occurs in two ways. See here. So there is possibility to it may be eliminated from this carbon or it may be this carbon. But according to Satzjeff, the adjacent carbon, the proton is removed from the adjacent carbon which having lower number of proton. Here it having 3 proton where this carbon having 2 proton. So it will be eliminated from this adjacent carbon. Moreover, the another concept is when it is eliminated, it will form the carbonium ion which is more stable. Secondary is more stable compared to primary. So here 2-butene is 80% major product and 1 butene is 20%, that is minol. So this is called the Satyjev rule. The hydrogen atom is preferentially eliminated from the carbon atom containing lower number of hydrogen atoms. Dehydrohalogenation of alkyl halide, second reaction of second method of formation of alkene. Hydrogen halide elimination in presence of strong base mechanism. It is two type of mechanism here also, E1 and E2 mechanism. E2 means bimolecular. Primary alkyl halides will give um, form alkene through this E2 elimination reaction. See here, here base is reacting toward the reactant, and it will form transition state, and then after transition state it will give alkene plus this product. Unimolecular reaction, it is for tertiary alkyl halide. Tertiary alkyl halide in first form, only one molecule is taking part, and it will, and this is a slow step, and it will give carbocation, and this carbocation will react, will abstract, base is again abstract this proton, and it will form alkene. And the order of reactivity is tertiary alkyl halide, secondary, and then primary. Orientation. Satyjev rule and Hoffman's rule. Here, Satyjev rule, it will form more stable 2-butene and less quantity of 1-butene. Whereas in Hoffman rule, here we are using strong base, tertiary alkyl butoxide. So in this condition, it is just opposite to Satyjev rule. Here we will get 1-butene. See how? Because this proton is less crowded, it is more acidic compared to this proton, right? Beta proton more crowded and less acidic. So this proton will be eliminated. So it will give 1-butene, 2-methyl, 1-butene. It is a major product, and this one will be minor product. Thank you very much for today's lecture.